So I stumbled upon this video by Presh Stallwalker. You can see the URL on the picture and I'll put it in the description too, but the question is generally, so you have this square 10 centimeter by 10 centimeter, and then you have a circle with a radius of 5 obviously, and then two quarter circles with a radius of 10, and then the question is find the area of the shaded regions using only primary school maths. And he then says trigonometry is allowed but calculus is not allowed, and proceeds to say that this was asked in China to 11-year-olds. No, I don't have a problem with the question, but I doubt very much that the way he solves it is something 11-year-olds would do, be they Chinese or otherwise. I don't think most people of that age don't know these formulas. So yeah, I could be, but I find it very hard to believe. So I made this video, and I'm going to try to solve it with far less use of cosines and sines than he does, and obviously I'm not going to use calculus. So the first thing I tried that didn't pan out is just to give every area a variable name and then try to come up with enough equations to solve the thing. But as I said, that didn't work out. So you can see the area that we are after, B. There's a lot of symmetry, so you can see two C's, four E's, two D's, which are all respectively the same area. The area B is also called a Lune, apparently. Lune is the French for moon, so it doesn't take a great stretch of the imagination to know where that came from. But let's see where this gets us actually. So we'll start with the square, which is everything. So the square is a plus 2b plus 2c plus 2d plus 4e, and that is obviously 10 times 10 is 100. Then we have the circle with radius 5, so it's 5 because, well, it's inscribed in a square with side 10, so the circle is a plus 2b, and the area of a circle is pi r squared, so r is 5, so that's 25 times pi. Quarter circle, which is a plus 2c plus b plus d. I'm going to write that a bit different. I'm just going to have the same order. So a plus b plus 2c plus d plus 2e. So that's 1/4 of pi r squared. R is 10 in this case, so we get 10 squared pi, or that is equal to also 25 pi. And that's the same as the little circle. So I got enthusiastic about that, and I thought, well, along the way this is going to help me somewhere, but it turned out it didn't. Now, what else can we get out of this? So you see this corner D, we have 4 of those, and so 4D is actually nothing more than the square minus the circle. So we have 100 minus 25 pi, 25 pi, or D is this over 4, so 25 minus 25 over 4 pi. You can also write this as 25 times 1 minus pi over 4. That's the same thing, but anyhow. And you can also note that D is actually equal to C plus 2 times E. Now this is not independent from the previous 3, because as you can see, well, it's the square minus the circle, so we have that already. So it's a linear combination of those two. So D is not independent, and so C plus 2E isn't either. We can also calculate C 2C plus A, so this, yeah, double, I don't know how to call this. So if I say half of A plus 2C, so that is actually this thing. Let me try that again. So that's the quarter circle minus the triangle. So what's left is this then. Which means the quarter circle is 25 pi, and the triangle is just half of the square, obviously, so the square was 100, so minus 50. So it follows that A plus 2C is 2 times this, so that's 50 pi minus 100. So we have A, B, B, C, and C. And so we have calculated that A plus 2B, which is the circle, that was 25 pi. And I keep doing this, 25 pi. And we have A plus 2C, which is 50 pi minus 100. You could also write this as 50 times pi minus 2, but same thing. And that's it, and you're stuck. So the problem here is, well, we have 3 variables and only 2 independent equations. And there's no way, I mean, not with this system, that you can calculate either A or B or C. And you need one of these 3 to figure that out. So we're done here. That's all we're going to get out of this. I'm not going to throw this away, because in the end you can calculate everything once you get to B. I'll show you how then. The next thing I tried, let's do something with triangles, right? So we have the same picture, and I have drawn a few triangles. So we have this orange triangle with side 5, which is the radius of the smaller circle, side 10, which is the radius of the
bigger quarter circle, so 10. And then the other side is 5 times root 2. And you can see that easily if you draw a line here. So you have a right triangle with sides 5, so the hypotenuse will be 5 square 2. So if we look at this triangle, this orange triangle, and you see this height h1 is half of the distance between s1 and s2. So if I can calculate h1, that will help me a lot. So we all know the area of a triangle is 1/2 times the base times the height. So the height is 2 times the area times 1 over the base. But we don't have the area, but we do have Heron's formula. And this is the sum of the sides of the triangle. So in our case, 10 plus 5 is 15 plus 5 times square 2. And then this formula says the area is the square root of s over 2 times s over 2 minus a times s over 2 minus b times s over 2 minus c. So if we do that, obviously s over 2 here is 15 plus 5 times square root of 2 all over 2. And then s over 2 minus a will be minus 5 square root over 2. So like that. So 5 square root over 2 is obviously 10 over 2 times square root, so you get minus 5 here. So you get 15 minus 5 square root over 2 all over 2. B is 10, so s over 2 minus b is 15 plus 5 times square root over 2 minus 10, so 10 is 20 over 2, so minus 20. We'll get, I'll just put this 5 square root first, and then minus 5, and that all over 2. And then last, s over 2 minus c will be 15 plus 5 square root over 2 minus 5, so this is 10 over 2. So we're left with 5, so we get 5 square root of 2 plus 5 all over 2. So I know you see something, if you see s over 2 and s over 2 minus a, you can see 15 plus 5 square root, and here it's 15 minus square root 5 times the square root of 2. So this is the form, if you multiply those two, you'll get something like a plus b times a minus b. And of course, we know this is a squared minus b squared. And the same goes for those two. So 5 square root of 2 minus 5, 5 square root of 2 plus 5. So a minus b, a plus b. And notice also we have a 2 in every term, so we'll get 2 times 2 times 2 times 2 is obviously 16, and the square root of 16 will be 4. So we'll get that the area is something like 1 over 4 times the root of something. Now, if we take those two terms, so I'll just write it down here, area will be 1 over 4 times the square root of 15 squared is 225 minus b squared, 5 times square root of 2, so 5 squared is 25 times 2 is 50. So we'll get that for the first two terms. And then the last two terms, so I'll have to multiply again. This times this, so we'll get again 50, and then as last term minus b squared, 5 is 25, obviously. Okay, so this is 1 over 4 times the square root of 175 times 25. But notice that this is 7 times 25. So we actually get is 1/4 of the square root of 7 times 25 squared. Or we get that the area is 25 over 4 times the square root of 7. And that's so the area of the orange triangle here. So now that I have that, I can calculate h1. So h1 will be 2 times the area over b, and b is 5 square root of 2. So h1 will be 2 times 25 over 4 times square root of 7 times 1 over 5 times square root of 2, and that boils down to, so if I say, let's get rid of this is 5, and this will be 2. So we're left with 5 over 2 times the square root of 7 over the square root of 2. And this is h. So now we have that. We can have a look at this green triangle here, which has sides h1, h2, and 5 being the radius of this smaller circle. So we get a triangle like this, h1, h2, and 5. So you can see that h2 will be the square root of 5 squared minus h1 squared, so we can just fill this in. So h2 will be the square root of 25 minus 5 over 2, and then square root of 7 square root of 2 squared. So that will be 25 minus 25 over 8. So square root will be 2, and this will be 4 times 7. So if we bring it to the same denominator, we'll get 8 times 25 minus 7 times 25 all over 8, and then the square root. So obviously this is 1 times 25, so we'll get 25, so the square root is 5, and 8 will be 2 times the square root of 2. So there you have it, this is h2. So now we have that, we can easily calculate the area of this triangle. So the area will be 1/2 times h1 times h2. So that will be 1/2 times 5 over 2 square root of 7 square root over 2 times 5 times 2 times square root of 2. So we get 2 times 2 times 2 is 8, and times 2 is 16, so this is 16. 5 times 5 is 25, and that's the square root of 7. So now that we have that, we can now calculate what is the area of this triangle here, right? The big one. It's the sum of the orange and the green one. So to get the total, that's just 2 times that, right? So let's go for that. So this is the triangle A(1) is 2. So the area of the triangle A(1) is 2 is 2 times this plus this, 25 over 4, times the square root of 7 plus this, and 25 over 16, square root of 7. So 25 here, and then 25 times square root of 7 times 2/4 plus 2/16. So this is times 4, that will be 8. So 25 square root of 7, 8 plus 2 all over 16. So that will be 8 plus 2 is 10 all over 16. So that's 5 over 8. 5 over 8. So that gives me 125. No. Yeah, 125 over 8 times the square root of 7. We also need the area of this one. So that's just 2 times the green area, which we calculated. So that's the area of the triangle O(1) S2, and that's 2 times 25 over 16 times square root of 7, so 25 over 8 square root of 7. But now we're stuck again, because, so as you can see, we'll need this formula and we'll need an angle to get the circle segment, the pizza slice if you like. And actually we need 2 pizza slices, so you can see that the Lune is actually so this pizza slice with the bigger circle, radius 10, and you have to subtract that from this pizza slice to get the Lune. Well, the segments, you have to subtract the segments. So we really need angles. Now, I'm not sure about 11-year-olds, so I won't comment on that, but you see, I have drawn some angles here, and basically I'll call this alpha, and so this is 1/2 of alpha, symmetry, and I'll call this beta, and then we have 1/2 of beta in this thing. So you can easily see that the sign of 1/2 of alpha will be h1 all over 10. So in this big triangle here. So let's say h1 all over 10. And h1 was 5 over 2 square root of 7 square root over 2 times 1/10. So if I say this is 5 times 2, I can just get rid of the 5. And that makes that the sign is the square root of 7 all over 4 times the square root of 2. So that means that 1/2 alpha is a sine of this square root of 7 4 times square root of 2. So alpha is 2 times the a sine of square root of 7 over 4 times square root of 2. Likewise, the sine of 1/2 beta will be h1 over 5. So we get 5 over 2 square root of 7 square root of 2 1 over 5, which boils down to square root of 7 over 2 times square root of 2. And so beta will be 2 times the a sine of this square root of so square root of 7 over 2 times square root of 2. Now we finally can calculate RB. So this is B. The Lune, you know. So we get that B is the circle with radius 5 segment minus the circle segment with radius 10, or minus the triangle 5 minus with side 10. So this gives us 1/2 times the square root of 5 times beta for the whole, so for this part. Minus the triangle, and we had that covered, so that was 25 over 8 times square root of 7, and that minus 1/2 10 squared times alpha. So this is for that part. Minus the triangle, and the triangle was 125 over 8 times the square root of 7. Right. So this is 25 times the a sine of beta was square root of 7 over 2 times the square root of 2 minus 25 over 8 square root of 7 minus 100 times the a sine of the square root of 7 over 4 times the square root of 2 minus 125 over 8 square root of 7. So if I put together the a sine terms, we get 25 times a sine of square root of 7 over 2 times square root of 2 minus 4 times a sine of square root of 7 4 times square root of 2, and that minus, so minus this plus that, so 25 minus 25 plus 125 is 100 over 8, so that's 25 over 2. Yeah, 25 over 2. Square root of 7, so that means I can also factor out this 25. And we end up with b being 25 times, so 25 times the a sine of square root of 7 over 2 times square root of 2 minus 4 times the a sine of square root of 7 over 4 times square root over 2 minus square root of 7 over 2. And that's the answer. And so now we have b, and so if you calculate that, that will be more or less 14.638 square centimeters was that, but we needed 2b, so 2b will be more or less 29.276 square centimeters.
So here are we back, and this time in Maxima, or wxMaxima. So remember, I got all these equations worked out, and then after a whole journey we came to this formula for b, or b being equal to 14.6 and something, and 2b actually being 29 point almost 3. So if I fill this in, b being that, and then 2b being that, you can see that Maxima gets the value of 2b, which is this, obviously. I also got d being 25 minus 25 over 4 pi. So if I give that 2, and then my 3 equations that I got here, so for the square, the circle and the quarter circle, and say solve, then I can get the values for a, c and e also, and that turns out to be a is this, c is this, and e is this. And so if you look at it as a number, so you get a is about 49, b 14.6 like we said, c is 3.9, d is 5.3, 5.4, and E is 0.7 all square centimeters, of course. You don't even need the value of D, so if I just fill in the value of B and then as for the formula here say that D is C plus 2E and calculate the C, A, B, A, C, D and E, you can see that D comes out same thing as it was, and again here you see the decimal values for this. So yeah, that's the solution of this problem. I'm not so sure that an 11-year-old could have done it the way I've done it, but I think there's a bigger chance for them to do it like I've done it than that Presh Stalwalker did it. But hey, and that was it for this video.